Now let's we said that the mean, right? So this function expected value of x, which is x times f of x, in fact is very similar to what we define as the x bar, which is just sum over just average over the values of xi. So I want to show something about the relationship between the distribution functions and the histogram. So this is the histogram of 50 students of so we this is just like um so there are so this is one, okay, this is eight, no, no, this is 11, this is 13, right? This is eight, this is four, and this is, I'm not sure, this is two, okay. So what we do is we just make the histogram of 50 many students in terms of their heights. So just one person, let's say this is the lower limit and this is the upper limit. Okay, there is no upper limit. So there is one guy, let's say this is, there is one guy who is whose height is shorter than 145 centimeters. Okay, and one guy which is 45 and 150. This is one guy here. Okay, this part. So in fact, this is 145 and let's say 0 centimeters. This is 145 and 150. This is 150 and 155, 155 and 160, and so on and so forth. So this is 145, 150, and 155. Okay, so one person here. And let's say this is 155 on 160, which is 8% here, 160 and 165, which we have 11, 13, 8, 4, and 2. Okay, I won't try to rest. So this is the histogram of this, right? So for example, what if I ask you, this is all the data that I have about the university. So if somebody just comes into the class, what is the probability that his or her weight is between, for example, between 155 and 160 centimeters? What is that probability? So what you will do is, what is simple rule? So in fact, the only information that I have is in 50 people, there are only eight students whose height is between 155 and 160. So the only thing that I can say is 8 over 50, which is 0.16 or 16%. Well, that can be the probability that a guy coming into the uh, class, that guy's height, sorry, is between 155 and 160 centimeters. Okay, this is the only thing that you have. Okay, so assume, I have a data of 250 many students. Okay, so the histogram is very much the same, but now the numbers change. So here I have five, I don't know, 10 here, 20 here, and so on and so forth. So again, if I ask you what is the probability that um, a guy coming to the class and his or her weight is between, let's say, I don't know, let's say this is 40, his or her height is between 155 and 160 centimeters. So what you will do is again, so there are 40 many guys and there are 250 people here. So 40 divided by 250, which is equal to 16% again. Is it 16? Yeah, 16 again, right? So you can say that what this information I can have, this is the best thing that I can say. Well, on the average, 16% is between 155 and 160. So assume we have a larger data, okay? So here, this is somewhere here. This is 140, 140, let's say. And again, if I ask you what is the probability that a guy coming into the class is between 155 and 160, there are 140 guys here. 140 divided by 1000, that's equal to 14%. And you can say that, 14%, the probability is 14%. The, so a guy coming to the class being between 155 and 160 centimeters is 14%. Now what I do is, that's again, I have 1,000 data, but now instead of making the data grouped or the histogram, the intervals of the histogram having a width of 5 centimeters, now they are with a width of 1 centimeter, okay? So there are how many guys whose height is 149, 150, 151, 52, 53, 54, 55, and so on and so forth. So again, for example, if I ask what is the probability that a guy coming to the class is 160 centimeters, okay, so let me just take this up to here. So this is probability 30, okay, this is 30. So 30 divided by 1000, that's equal to what? 0.03, which is equal to 3%. So the probability that a guy coming to the class is 159 centimeters is equal to 0.03. That's equal to 3%. Okay. You can do the same thing here. You can just look at this one, 159. Again, that's equal to, I don't know, 350 here. Since the data changes, well, the probability may change, okay, because there are different data here. This is 1000, this is 10,000. So the probability here is again what? 0.032, which is 3.2%. That's the probability, okay? Well, that's the histogram of 100,000 people. And of course, what we can do is instead of writing the frequencies here 1500, you can just divide them by what? You can divide them by the number of data here. Okay, so here I have, right, so here I have what, this is divided by 100, sorry, these are the frequencies, okay, not the frequency, but sorry, this has the percentages, okay, the percentages. So now if somebody asks you, well, what is the probability that um, somebody comes into the class and his height is 159, then you don't need to find the number here and divide it by this number, okay? What you can do is you can just directly say this number, which is 0.03. Or if I ask you what is the probability that a guy comes to the class and his or her height is between 160 and 161 inclusive. So what you do is, okay, just look at here, and so 160 and 161. So what you do is you just find the what? The corresponding percentages here, okay, and then add them up. I don't know, these are, one is 0.035, the other one is 0.036. So if you sum them up, this is equal to 0.071. Okay, and this is the histogram of infinitely many data. See, it's a smooth curve. Okay, it's a smooth curve. So if I ask you what is the probability of a guy coming to the classes between 155 and 160, okay, 155 and 160 inclusive, what you do is, okay, 155 and 160, what you do is you just go to here, look at the height of this rectangle, and look at the height of this rectangle, look at the height of this rectangle, and so just look at the height of 5 or 6 rectangles, because 155, 160, all of them inclusive, and then add them up, okay, to find the required probability. In fact, this is the thing that we are doing in calculating the probabilities in continuous random variables, right? So if I ask you what is the probability that a guy is between 155 and 160, right? What you do is you just do it like this, and you find the area here, okay? Finding the area is exactly the same thing as finding the corresponding percentages of these particular rectangles. Okay? So in fact, a distribution function is nothing but it's a histogram with very, very thin bins. Okay, so this is so here the interval is 1 centimeter. If the interval becomes very, very thin, okay, if it is 0.001 millimeters, then you approximately have this probability distribution function. Okay, so let's stop it here and we will continue in the next video.